lesson 11.2, we're going to look at arithmetic series. The definition of an arithmetic series, now we just looked at arithmetic sequences in 11.1. An arithmetic series would be to find the sum of the terms of an arithmetic sequence. So you might be finding the sum of the first 8 terms of a sequence, or the first 15 terms of a sequence, for example. Okay? And we'll look at an example here, finding the sum of an arithmetic series, the sum of the first 20 even numbers, beginning with 2. Now, obviously, you could write them all out and add them all up, but we have formulas here. And we're going to look at this one right now. And you need to write these down. There are 2 formulas, and it depends on what we know. Sorry about that. There's 2 formulas, and it depends on what we know. One is, if you know the first and the last term, you're going to use this formula right here. And it says S sub n. That means the sum of the series for n terms. N is the number of terms. That capital S with the subscript of n means the sum of whatever number of terms. So n right here would be whatever you're finding the sum of how many terms. A1 is the first term. A sub n is the last term. So if there were 15 terms, it would be A15. So that's the formula. Obviously, if we know how many terms we're summing, we know the first and the last term. If we don't know the last term, we're going to use this formula. Again, the sum of the series of n terms is n divided by 2 times, in square brackets there, 2 times the first term. Remember, this is the first term. N minus 1, n is the number of terms. D is the common difference that we dealt with in the first section. Common difference in an arithmetic sequence is what you add between terms. Okay, so let's look at this example now. Find the sum. So the sequence is basically 2, 4, 6, all the way up to, now if you think about the first 20 even, that would really be going up to 40. Okay, because we can figure out the last term. So A1 is 2, and A sub n is 40. And we know n is equal to 20, because if I had the first 20 even numbers, obviously starting with 2, we'd be going up to 40. So we know A1, we know an, or the last term, A sub n, A subscript of n, and n equals 20. So we are going to use, I'll use the first formula. You can actually use either formula here, but if I use this first formula right here, we're going to take n divided by 2. Well, n would be 20, so 20 divided by 2 times the first term, which is 2, plus the last term, which is 40. So 20 divided by 2 is 10. 2 plus 40 is 42. So it'd be 420. So there is using the first formula. Now, we could actually use the second formula. N is 20, because we can figure out n. A1 would be the first term. Again, n is 20, and the difference, I'm showing you with the second formula, we could figure it out too. We're doing S sub 20, because we're doing the first 20 even numbers, equals 20 divided by 2 times 2 times A1, which is 2. I'm going to put a square bracket there. Plus n minus 1. Well, n is 20, so n minus 1 would be 20 minus 1, or 19, times the difference of 2. I'm going to show you this formula would work here, so we could actually use either one. 20 divided by 2 is 10. Inside here, I get 4 plus 38. This is 4. This is 38. So I really have 42 inside there. 10 times 42 is 420. So notice I got the same answer using either formula. Okay, if we go to our next one, now we're going to kind of work backwards and find the first term. So given that S sub n equals, so we're looking at kind of that second formula there, we know this, S subscript 31, or S sub 31 equals 124,000. Okay, that means that n is equal to 31 because of that right there. D is equal to 100. We need to find A1. So I'm going to do S subscript 31 equals 31 divided by 2, and then 2 times A1 plus 31 minus 1, which would be, because there's 31, because we know n is 31, times D, and D is 100. Now let's do a little simplifying. S sub 31 we know is 124,000, so I'm actually putting in what they told me the sum of the first 31 terms are. Okay, equals 31 divided by 2 is 15.5, so that's coming from that. And then this is 30, so inside here I have 2A1 plus 30 times 100, which is 3,000. Let's extend the page a little bit here. All right. Let's distribute. We could actually divide by the 15.5, but I'm going to distribute. So 124,000 equals 15.5 times 2A1 would be 31 times A1 plus 15.5 times 3,000. If you use your calculator to do that, is 46,500. We're going to subtract 46,500. So 31 times A1, remember we're supposed to find A1 here, equals, and then if you do that subtraction on your calculator, you should get 77,500. Then we're going to divide by 31 to cancel that out. So A1 is equal to 2,500. So we're working backwards in that second formula using algebraic properties to solve for A1. Find the first four terms. So we're finding the first four terms. And here's what we're given. We know A1 is this, A sub n is 29, and we know the sum is 129. So A1 is first term, A sub n is last term, and we know that the sum, but we don't know n here. So in step 1, we're going to find n. There's a couple steps to this problem. So I'm going to use this first formula. Sn equals n divided by 2 times A1 plus AN, which was the first formula we looked at. We know that is 129. So we know that the sum, we just don't know what n is. We're going to work backwards to find n. N divided by 2, but we know A1 and AN. This is first and this is last. So this would be 14 plus 29, or really I have 43 inside there then, is equal to 129. Let's go ahead and get rid of the divide by 2. We're going to times 2 to cancel it out, so I'm going to times by 2. So I have 258 over here when I multiply 2 and 129 equals n times 43, but I'm going to write it 43n. Now I'm going to divide by 43. So n is equal to 6. Okay, we find n. Now this is step 2 then. We know there's 6 terms. Now we're going to find d. So we're going to use the other formula. Sn equals n divided by 2. and then we had 2a1 plus, in parentheses, n minus 1 times d. Let's substitute in here. We know Sn is 129. We now know n, so we're using the fact that we found that n is 6, so 6 divided by 2. Okay, 2 times a1, which is 14, plus, we know n is 6 now, so we're going to have 6 minus 1 right here, which is going to be 5, and then d. So 129 is equal to 3. This is going to be 28 when I multiply 2 times 14 plus 5d. Now we're going to distribute. So 129 is equal to 3 times 28 is 84 plus 15d. Subtract 84. So 45 is what we get there. That's gone. Is 15d. We divide by 15. So d is 3. And the reason we need that is we know there's 6 terms. Now I can find the first 4 terms. So we know the first term again was 14. So here's the terms in the sequence. The first one was 14. Remember, that was given, A1. We know we add 3 between terms. So that means 17. Then we're going to add 3 again, 20, and 23. There would be the first 4 terms of that sequence. All right, then we get into the last example, which is sigma notation. This symbol right here, kind of looks like a funny looking E, is the sigma symbol. It's a summation symbol. Okay? Evaluate a sum that's in sigma notation, and you need to know how to do this. All right? When you're dealing with sigma notation, you are going to use that first formula, which is this one, for finding the sum of a series. Okay? Now, what this really means in sigma notation, the longhand way, and I'm not going to go through this whole thing, but it really means, you see how there's an expression right here, and this means start at the bottom number. So I would sub 3 in for k, and that would yield me 2 times k, which is 3, plus 1. Well, that'd be 6 plus 1, which is 7. So that would be when k is 3. Now, what the sigma symbol means is then you'd put in 4. And you'd have 2 times 4 plus 1, which is 8 plus 1, which is 9. Okay, then you'd put in 5, and you'd keep going. So I'd have 2 times 5 plus 1, which is 10 plus 1, which is 11. I would keep going, putting in all the way up to, do you see how the top number is 10? So if I put in 2 times 10 plus 1, which would be 21. So I'd keep summing all those up, and then I would add them all up, and that would be my sum. Now, sometimes you might go from 3 up to 99, so that would be very long to write out all the terms. We could probably do it here, but here is kind of the shortcut with sigma notation. Find A1, which is the first term. To do that, you plug in the bottom number, meaning the bottom number in this case is 3. So if I was going to find A1, and I already really did that right here, I put in the 3 for k. So I have 2 times 3 plus 1, which is 7. There's the first term. Okay? Then we're going to find A subscript n, which is the last term. To do that, you plug in the top number for k. So the top number would be this 10. So to find AN, I'm going to do 2 times 10 plus 1, which is 20 plus 1, or 21. So there's A1. There's the last term, A sub n. And again, I really did that over here when I was talking about the longhand way of how to do this. Okay? So now if you think about the formula that we have and what we're using this one. S sub n equals n divided by 2 times A1 plus AN. Okay, well I know A1 is 7. I know AN is 21, so I know those two. To find the sum, which is what they want you to do, S sub n, or subscript n, we really need to know n. Here's the shortcut to find n. To find n in sigma notation, you take the top number, subtract the bottom number, and add 1. So in this case, my top number, as you can see above the sigma symbol, is 10. My bottom number is 3. Many times that will start at 1, but not always. And then I add 1. So 10 minus 3 would be 7. 7 plus 1 would be 8. That means there would be 8 terms, or that n is equal to 8. So again, the shortcut is top number minus bottom number plus 1. So I really plug 8 in here, so it's 8 divided by 2. So let's extend the page here a little bit. 8 divided by 2 is 4. 7 plus 21 is 28. So to find my sum, I take 4 times 28, which is 112. Now, if I would have kept doing it the longhand way like I started out, added them all up, that's what I would have gotten. But sometimes you might be going from 3, for instance, up to 150. You would never want to write out 150 terms and substitute in for k 150 times. This is the shortcut method to find the sum in sigma notation, and you need to know this.